Download this code from codegive.com, link in the description below. Optimizing performance by ignoring irrelevant scripts. When striving for optimal web performance, a crucial aspect is to minimize the overhead caused by scripts. This includes reducing the number of scripts loaded, optimizing their execution, and ensuring that only necessary scripts contribute to the rendering and interactivity of your website. One often overlooked technique is to effectively manage the loading and execution of scripts that might not be immediately relevant to the current page or user interaction. This can be achieved by adding these irrelevant scripts to an ignore list or deferring their execution until they are actually needed. This tutorial will delve into the concept of ignoring irrelevant scripts for performance improvement, covering 1. Understanding irrelevant scripts *, identifying scripts that aren't critical for initial page load and interaction. 2. Why ignore irrelevant scripts, *, explaining the performance benefits of this approach. 3. Methods for ignoring or deferring scripts *, exploring various techniques and their use cases. 4. Implementing script ignoring / deferral with code examples *, demonstrating practical implementation using HTML attributes, JavaScript, and module bundlers. 5. Dynamic script loading with intersection observer * loading scripts only when they become visible in the viewport. 6. Analyzing performance impact * measuring the effectiveness of your optimization efforts. 7. Considerations and best practices * addressing potential challenges and ensuring a smooth user experience. 1. Understanding irrelevant scripts. An irrelevant script is a JavaScript file or inline code block that is not essential for the initial rendering of the page or for critical user interactions immediately after the page loads. Identifying these scripts is the first step towards optimization. Here are some common examples. Analytics scripts * while essential for tracking user behavior, analytics scripts often don't directly contribute to the visual rendering or functionality of the page. A/B testing scripts * scripts used for A/B testing experiments may not be necessary for all users or on all pages. Scripts for features below the fold * if a script controls a feature that's not visible in the initial viewport, i.e., requires scrolling, it can be deferred. Scripts for specific user roles or conditions * scripts that only apply to logged-in users or users with specific permissions can be ignored for other users. Third-party widgets * social media widgets, comment sections, or embedded content that aren't critical for core functionality. Scripts implementing less critical animations or enhancements * cosmetic features that improve the user experience but aren't essential for functionality. How to identify irrelevant scripts * analyze your codebase * review the purpose of each script and determine its importance for the initial user experience. Use browser developer tools * the coverage tab in Chrome DevTools, or similar tools in other browsers, helps you identify unused JavaScript code. This can highlight scripts that are loaded but not actively used on a particular page. Performance profiling * use tools like Lighthouse or Web Page Test to identify scripts that are contributing significantly to page load time or blocking rendering. 2. Why ignore irrelevant scripts? Ignoring or deferring the execution of irrelevant scripts provides several performance benefits. Faster initial page load * by delaying the loading and execution of non-essential scripts, you can reduce the time it takes for the browser to render the page, improving perceived performance. Reduced main thread blocking * JavaScript execution blocks the main thread, which is responsible for rendering the user interface. Deferring scripts allows the browser to prioritize rendering and user interactions, leading to a more responsive experience. Improved First Contentful Paint, FCP, and Largest Contentful Paint, LCP. These metrics measure the time it takes for the browser to render the first content and the largest content on the page. Ignoring unnecessary scripts allows the browser to focus on rendering these important elements faster. Lower CPU usage. By reducing the amount of JavaScript code that needs to be parsed, compiled, and executed, you can reduce CPU usage, especially on mobile devices. Improved time to interactive, TTI. This metric measures the time it takes for the page to become fully interactive and responsive to user input. Deferring non-essential scripts can significantly improve TTI. Better Core Web Vitals scores. Ignoring or deferring scripts contributes to improved scores for FCP, LCP, and TTI, which are core web vitals used by Google to rank websites. 3 methods for ignoring or deferring scripts. There are several ways to defer or ignore irrelevant scripts. The choice depends on your specific needs and the nature of the script. Defer attribute. The defer attribute tells the browser to download the script without blocking page rendering and to execute the script after the HTML has been parsed. Scripts with the defer attribute are executed in the order they appear in the HTML. Use case. Ideal for scripts that don't depend on the DOM being fully loaded but don't need to be executed immediately. Good for analytics, some third-party widgets, or scripts that enhance the page after it's rendered. Async attribute. The async attribute tells the browser to download the script without blocking page rendering. The script is executed as soon as it's downloaded, without waiting for the HTML parsing to complete. Scripts with the async attribute may execute in any order. Use case. Ideal for scripts that are independent and don't rely on other scripts or the DOM being fully loaded. Suitable for analytics, with careful consideration, add scripts or scripts that fetch data and update the page asynchronously. Dynamic script loading. With JavaScript you can dynamically create a script element in JavaScript and append it to the DOM. This allows you to load and execute scripts based on specific conditions or user interactions. Use case. Highly flexible for loading scripts on demand, based on user behavior, viewport visibility, or other factors. Allows precise control over when and how scripts are loaded. Conditional loading with modules and code splitting. With module bundlers. Modern module bundlers like Webpack, Parcel, or Rollup allow you to split your code into smaller chunks, modules, and load them on demand. This is particularly useful for complex applications. Use case. Excellent for large applications with many features. Allows you to load only the code required for the current page or user interaction, reducing the initial payload. Using the script tag. Place code inside the script tags that will only run if JavaScript is disabled. This can be useful for providing fallback content or features when JavaScript is not available. This won't ignore or defer loading the JavaScript itself, but it prevents its execution. Use case. Provides fallback content for users with JavaScript disabled or error handling if a critical script fails. Intersection Observer API. Allows you to detect when an element enters or exits the viewport. You can use this API to load scripts only when they become visible. Use case. Ideal for loading scripts for elements that are below the fold, such as images, iframes, or interactive components. For implementing script ignoring/deferral with code examples. Let's illustrate these techniques with code examples. Example 1, using defer attribute. In this example, analytics.js and widget.js are loaded with the defer attribute. They will download without blocking the HTML parsing and execute after the HTML is parsed in the order they are defined. Main.js will load immediately, as there's no attribute indicating to defer. Main.js runs before the defer scripts and hence may be necessary for base operations or elements. Example 2, using async attribute. Here, analytics.js and addscript.js are loaded with the async attribute. They will download without blocking the HTML parsing and execute as soon as they are downloaded, regardless of the order in which they appear in the HTML. Main.js will load immediately, as there's no attribute indicating to defer. Example 3, dynamic script loading with JavaScript. In this example, the load script function dynamically creates a script element, sets its src attribute to the specified URL, sets async equals true for asynchronous loading, and appends it to the head of the document. It also includes a callback function that is executed when the script has loaded. The script is loaded when a button is clicked. Example 4, dynamic script loading with modules and code splitting, using webpack. *webpack.config.js*. *src/index.js*. In this example, webpack will split the code into chunks. The base.js code will be bundled in the initial bundle.js, while myFeature.js will be in a separate chunk. This separate chunk will only be loaded when the load feature button is clicked. The /*webpack chunk name, myFeature*/magic comment tells webpack to name the chunk myFeature. Example 5, using intersection observer API. In this example, an intersection observer is used to monitor the lazy load area element. When the element becomes visible in the viewport, is intersecting is true, the lazy loaded feature.js script is dynamically loaded and appended to the document body. The observer is then unobserved from the element, preventing further script loading when the element re-enters the viewport. 5. Dynamic script loading with intersection observer, detailed. The intersection observer API is particularly powerful for loading scripts based on element visibility. Here's a breakdown of the process. 1. Create an intersection observer ***. Entries, an array of intersection observer entry objects, each representing a change in the intersection state of the observed element. **observer, the intersection observer instance itself. *root, the element that serves as the viewport for checking visibility. Setting it to null uses the browser viewport. *root margin, adds a margin around the root element. Can be used to trigger the observer before the element is fully visible. *threshold, a value between 0 and 1 representing the percentage of the target element that must be visible for the observer to trigger. A value of 0 means the observer triggers as soon as any part of the element is visible, while a value of 1 means the entire element must be visible. 2. Observe an element *. This tells the observer to monitor the target element for changes in its intersection with the viewport. 3. Handle intersection changes in the callback *. Entry. Is intersecting, a boolean indicating whether the target element is currently intersecting with the root, viewport. *entry.target, the target element that is being observed. *observer.unobserve, entry.target, stops observing the target element. This is useful if you only want to load the script once. 4. Implement the load script function. As shown in example 3, this function dynamically creates a script element, sets its src attribute, and appends it to the document. 6. Analyzing performance impact. After implementing script ignoring /deferral techniques, it's crucial to measure their impact on your website's performance. Use Browser Developer Tools. The Performance tab in Chrome DevTools allows you to record a timeline of your website's activity and identify bottlenecks. You can see how much time is spent loading and executing scripts. Use Lighthouse. Google's Lighthouse tool provides a comprehensive audit of your website's performance, accessibility, and best practices. It will highlight opportunities to improve performance, including script optimization. Use Web Page Test. Web Page Test is a free online tool that allows you to test your website's performance from various locations and browsers. It provides detailed metrics, including page load time, first contentful paint, FCP, largest contentful paint, LCP, and time to interactive, TTI. Monitor Core Web Vitals. Track your website's Core Web Vitals, LCP, FID, CLS, in Google Search Console. These metrics are important for SEO and user experience. By analyzing these metrics before and after implementing script ignoring/deferral techniques, you can quantify the improvements and fine-tune your optimization efforts. 7 Considerations and Best Practices. Dependencies. Ensure that you don't defer scripts that other scripts depend on. Carefully analyze your script dependencies to avoid breaking functionality. User experience. While optimizing for performance, prioritize a smooth user experience. Avoid delaying scripts that are essential for critical user interactions. Progressive enhancement. Implement your website using progressive enhancement, meaning that core functionality should work even if JavaScript is disabled. Use NaScript tags to provide fallback content or features. Testing. Thoroughly test your website after implementing script ignoring/deferral techniques to ensure that everything is working as expected. Test on different devices and browsers. Content Security Policy, CSP. If you are using CSP, make sure that your policies allow the loading and execution of dynamically loaded scripts. Error handling. Implement proper error handling for dynamically loaded scripts. Provide informative error messages to the user if a script fails to load. Prioritize critical scripts. Focus on optimizing the loading and execution of the most critical scripts first. These are the scripts that have the biggest impact on the initial rendering and interactivity of your website. Avoid long tasks. Break up long JavaScript tasks into smaller chunks to prevent blocking the main thread. Use techniques like set timeout or request animation frame to schedule tasks asynchronously. By carefully considering these factors and following these best practices, you can effectively ignore irrelevant scripts and significantly improve your website's performance, leading to a better user experience and improved SEO. Remember that performance optimization is an ongoing process, so it's important to regularly monitor your website's performance and make adjustments as needed.